This is Rohit, and I'm the tech lead
Rohit,
for.
your voice is really low. Can you be a little louder, please?
Okay, one sec. Okay, is this better?
Let's ask the audience. Guys, you can hear him properly?
Okay, a lot of yes. That's fine. Okay, okay. Hi everyone. This is Rohit, and I'm the tech lead for FPG project in Mumbai location. Um, I'll be giving a few sessions, probably 4 sessions I have planned for now. But maybe we can extend to 2 additional because the initial sessions are mostly like a groundwork to get started. So I'll just give you a brief what I'll be covering in these sessions. So for today's session, which I'll be giving a brief overview of the architecture of microservices, how that is developed usually in the normal development world, and what are the different variants what can be used in that architecture. I'll give you some practical understanding. Will be going hands-on with different endpoints like get, post, put, delete options. I'll giving you explanation on which methods are used for what. We'll go ahead with the some of the examples using Spring profiles and configuration properties, like how to read the configuration properties in the best possible way. And then we'll have some best industry standards which is actually required when we create microservice. So in an enterprise application, you will end up having 10 to 20 or sometimes 25 microservices. So it will be cumbersome to have the same configuration or same models and DTOs being used in every microservices. So there are some best practices which needs to be involved over here to have a faster development, so that the development should be concentrating on the business logic rather than the setting up of new microservice every time. And we'll have some hands-on on the Swagger as well, Swagger integration, which will enable us for testing for developers and testers as well, to check the input and output. That was for the first session for today. The subsequent sessions will be like the next week we'll be having the ORM that can be used in Spring Boot. There are 2 variants, which either we can use the Spring Data, which internally uses the entity manager to map the entities to the database tables, or we can use the Hibernate, where you can explore the options for the criteria API and different restrictions and projections to query the database. And we'll explore the other options as well. If there is a huge query that needs to be executed, how we can call the store procedure from our Java code. So that database related thingy will be covering in the second session, which will be the next week. Then we'll move on into the Spring security and the API gateway. So just to remind, like, we'll be taking one use case in mind, and we'll keep developing on that use case. At the end of the day, I'll be pushing that to GitHub. I'll share that link. But yes, we'll keep enhancing that use case so that we can integrate as much as possible. Spring uh, modules. So the third session, as I said, is the Spring security. Will secure all the endpoints using WAUth and JOT. That's JWT, JSON Web Token. We'll introduce the API gateway as well, wherein all the network calls are not hit directly to the microservice, but it's going through the API gateway. And then we'll move on to the Spring Cloud, where we'll be exploring the cloud configuration, circuit breaker, Hystrix dashboard, and Spring Sleuth for tracing of the API um, API flow from one microservice to the other. Okay, I'll quickly share my screen to start off with the architecture. I'll just give you a brief understanding how that goes. Okay, I hope you guys can see my screen. Just 1 or 2 yeses is fine.
Yes, yes.
Okay, fine. Okay. Okay. I don't have any PPT. I just have a sketchpad. I'll try to explain. So, what is a microservice? First of all, microservice is simply a component which can be shipped, deployed, and it can be we can start using it. So basically, it is like the your Java code over here, and it's your database. So it's the database over here and the Java code, and this, if it is shipped together, this becomes one microservice. So uh, uh, ideally, the what the architecture says is that a single microservice should be developed in a such a way that it should be scalable, it should be resilient. I mean, a minimum downtime of the application. uh, so these are some of the important attributes what needs to be taken care while we are developing the microservice. So but definitely, yes, to have this thing enabled, we'll have to use the Spring features like the Spring API gateway, the hystrix, the circuit breaker. If there is any failing API, how we'll fall back to the different API call so that the response has been given. So ideally, the architecture says that every microservice should have its own database. So every microservice should have its own database. It's something like this. Ideally, this is a very practical scenario where some of the applications do use this, wherein it makes sense, wherein you'll concentrate the entire microservice will be concentrating on one specific business logic, and you won't be messing up with the other the databases which is being used by the other people or other module. But again, some of the microservice or some of the projects, what they prefer is have the microservice have the backend logic uh, uh, modularized into different microservice, and point it to a single database rather than multiple database. What is the positiveness over here if we are having a single database? If we have any kind of data processing, some what do you say, some machine learning algorithms that needs to be executed, that can be used from a single data set which is present in one single database rather than the multiple database which can be combined and pushed into one single data lake where they can have so that will essentially become a different project altogether if there is a different database, and if they want some data processing to be processed into different database, so they will have this module which can be pushed into a single data lake, and then they can perform that operation. It depends upon your project, honestly, how you want to architect it. uh, Ideally, single microservice should be having a single database, but if it is not having a huge data set, it is preferred that you have a single database and different microservices pointing to the single database. The advantage over here is the one other advantage of using single database with different microservice is the ORM. For instance, say this is a user microservice. This is a user microservice and this is a address microservice. Now a user can have multiple address, but you cannot have the ORM enabled over here. For instance, a user has multiple addresses, so a user won't be we won't be mapping one to many over here as address, because this database is not having the address table, so that is not possible. So it makes sense if we keep a single database, so every microservice is connecting to the single database, so it is having that table. It understands that the entity is having where it needs to be mapped, the address that needs to be mapped into. So that's pretty much it, what can be done. But over the period of all the sessions, you will understand as and when we'll be having all the components. So this is one of the microservice wherein, again, if I put a API gateway in front, uh, the API gateway will be something over here. API gateway, ideally speaking, API gateway is responsible for routing to different microservices where it needs to go. So and ideally, API gateway is also responsible for authentication and authorization. If you are authorized to access the microservice, only then it will allow the microservice to be accessed. The network call will proceed, else it will just return from here rather than going into microservice. In a way, this m- m- makes us concentrate on the business logic within the microservice, and we are not worried about whether the user coming in is authorized or not, because that is already taken care by API gateway. Further in the session, we'll be having something, as I said, circuit breakers. So if one specific API call uh, is failing from fetching the database for n number of reasons, might be column mismatch, column name mismatch, uh, data constraint issue, some issue. So if the API is continuously failing, we can configure that API to fail, say we can say retry for 5 times, and then you can fall back to a different method wherein we'll keep the data cached. The data for the API will be cached into a Redis or some data store or key value database, wherein on the fallback method it will just go fetch the old data, you can see it as a stale data, and provide that as a response. Rather, failing the API, it is worth if we keep retrying. If that works, if it doesn't work, we'll fall back to the different method and give the response. That is one of the heuristics. Then comes Spring Sleuth, which will be demonstrating in spring in session 4. If an if my web application or a mobile application access an API which goes through an API gateway and through a microservice which internally calls the different microservice. So how can I come to know that this microservice is fail at what point? We won't come to know. So that is the reason why Spring Sleuth comes into a picture, wherein we can trace the microservice, the way it flows from API gateway to one microservice 1 to microservice 2, and that way we come it clears out the picture, like what is the exact flow and where it is failing, if any. Okay, so let's jump on to some practical example. I'll start. Most of you guys might be aware about the. Any questions so far? I'm sorry.
Yeah, one question. Do
Yeah.
you seem to favor a single database across all the microservices, right?
Yeah.
And do you see any problems with that? Say there may be many multiple instances of each microservice, and each may be having its own connection pool to the same database.
Mhm.
Or do you see the chance of database getting starved for connections?
No. So over here in the advanced lecture, what we usually do is we don't keep a single database. We keep master and slave configuration, wherein
Yeah.
read is done from the slave database, and from master is usually used for write. So that won't be having much of a problem in that case, I guess.
Mm, all right.
Yeah.
But you're still connecting to one database, right? And usually there is a connection. We have had these issues. Of course, it wasn't a clustered database, I presume, but
Mhm.
when you have so many services connecting to the same database, each one has its own connection pool, and the database simply doesn't allow so many connections.
Yeah, true. That makes sense. But usually, what happens is uh, when you spin up this microservice, you tend to keep only the slave database connection information, and when it's deployed on AWS, we have a configuration wherein it usually refers the connection pool. From the connection pool, the connections are uh, given out to the slave in a proper manner, like slave instances rather than the master.
All right.
Okay.
So,
Uh,
hi Rohit.
hey.
I also want to know the strategy if your database, master database fails.
Okay, so that is altogether another topic. Uh, okay, who's this? If I'll answer your question, who's this? I'm sorry.
Yeah, Rohit, I'm Tanmay.
Tanmay. Okay, fine. I'll answer your question later.
Yeah, sure.
One to one. Okay. I'll quickly proceed because we are already 20 minutes into the schedule and I just need to demo a few things. Your question was, what if the master database fail? What is the procedure? What needs to be followed, right? In that case,
Yeah.
master instance. Okay. Okay, so usually when the master instance fail, I'll quickly try to explain you. When in the connection pool, usually what happens is you have the pinging going on onto the database. If your write operations are specifically onto the master instance, it keep pinging the connection if it's alive or not. And if it's not alive, then you can definitely configure it to reconnect and like recreate that bean for the connection pool. That is definitely a way to do it. Quickly say we want to create an address book. So this will be the project which will be taking it forward and having it developed in all the sessions. So let's start with the address book. So the first of the microservice what we can create over here is user microservice. So I'll just jump on to start.spring.io and quickly create one microservice which will be dot phone book. Phone book user. Okay. I'll add few dependencies which will be web, since we are creating web application. We'll have the data JPA. We'll have the dev tools for hot reloading. We'll have the actuator. We won't be using the actuator much, but later on in the sessions we'll be requiring that. Lombok for the getters and setters. And I'll give you a brief introduction about the Liquibase as well, which was essential. Okay, pretty much it. Okay, I'll quickly generate this. Okay, I'll just import that. Okay, so that's imported. I'll just quickly add some properties over here. I'll use YAML file. You can definitely use properties, no harm. Application YAML. So I'll be explaining few concept of profiling as well, Spring profiling. So for now, I'll just create a file which is for specifically for local. So application hyphen local YAML file. The convention over here is application hyphen should be there, and then the profile name goes. So that can be either local, QA, UAT, prod, that can follow. So here's a one. for local right now. I'll just set up the port as 9000 for now, and I'll quickly disable the Spring data because I won't be using, I mean, I'll be using it today, but not for now. Not even Liquibase core, because that will be looking for the database details. Number is fine. Okay. Okay. I'll quickly create one resource, which is one endpoint for now, which is resource. So all the endpoints are termed as resource rather than controller. That's the one of the convention that we use. So usually in the user controller, user resource, you will have all the usual methods, which is get, post, put. I'll start with the a creation to create a user. So public create. Okay, so I will require a user object. So I would require a DTO now. So whatever data that comes from UI or from the client side is kept as taken into a DTO and then transformed into a model object. So a DTO for now. So that's the user DTO. So private. Okay, you might need ID later on, but not now, but I'll add it for now because we'll be storing this information into the database. So no getters and setters, so I'll use the Lombok stated data. So that usually it creates the getters, setters, two strings and equals method by default. And I would require, not necessarily, that's fine. Okay, I don't need no, but data is fine for now. So this will be the post mapping, and I'll take the input as user DTO, and this will be my request object. So if there is any object which is coming up as an input, that's marked as request object over here. And for now, what I will do is I'll create one user or DTO for now over here so that it can respond back with something. So that's the reason. And in the constructor, what I'll do is, in fact, I don't need that for now. It will not necessary. Okay, this dot.
This won't work for static. Why don't you just return the same object? Just return the same object and set a ID. Return the same object.
In fact, okay, that's fine. Okay.
I mean, Wildcard otherwise. So
yeah. Okay. So that's pretty much it. So if I try to run this, and it should run on port 9090. One of the thing what we need to add into the configuration is the profile, in what profile it should run. So this is my user local profile. So I'll just mention the user VM option is -t spring dot profiles dot active equals local. Okay, and PP user, that's it, apply. Okay, so if I spin this up, so this should spin up using this property. That's the local property. Okay. Data source. Web dev tools Lombok dust, I think. Okay. Sorry, so that dependency was included into the cache. So it was trying to connect to the database. So while that is spinning up, I'll just include Swagger as well into this dependency, so that we don't have to use the browser to test this. So we have the artifact, which is the Spring Fox Swagger 2. Okay, okay, this works. And we'll require one other thing is the UI. So our dependency Spring Fox Swagger UI Spring Fox 2.92. Okay, this should work. Okay, while this is up, I'll just quickly check once. Okay. So REST controller. That's 9000. Requested username, password, no. First name, last name. Okay, first name. Oops. Port 8080. I'll just stop this for now. 1 sec.
Wait, sorry to interrupt. I think you ran the main class directly. Instead, you need to run from the profile.
But oh, okay, I executed from here. Okay, sorry.
Would not pick the profile.
But it showed that it is picking up local profile. I saw in the log. 1 sec. Okay, someone just commented that there's a typo in my. Oh, okay. Thank you. So there's a typo. The name is application.yaml. Okay, thank you. I'll just rerun this again. Okay, while this is spinning up, I'll have the configuration added for the Swagger, which is config Swagger config. Meanwhile, okay, yeah, that executed. Thank you. So right now I'm adding all the DTOs, models, configuration into one single microservice, but later on I'll be just moving out into another library, which which will be added as a dependency into each and every microservice. So to enable Swagger, as usual, you will find it in the documentation as well. So configuration @enable Swagger again. Okay, I just need to refresh my Maven dependency. Okay, yeah, enable Swagger 2. So we have this docket which we need to return that. So I have the docket equals to new docket, so which takes the documentation type as Swagger 2, type as Swagger 2 dot select dot APIs request handler selectors, which will be my base package, and my base package will always be, so there is some guideline what need to be followed, that in a project there would be a single package that needs to be configured for each and every microservice. So org.pb in our case is a package, and all the resources should be in the resource, because once we move out this configuration into another library, it will automatically pick up from the microservice from the resource folder. That's the objective behind this. So after the base package, we have the path. So path selector would be any. Build. Okay. Guess. Okay, this is additional. Okay, so I can simply return this. That's fine. And okay, so that's the configuration. So if I rerun this again, this should work. Swagger should be integrated into this microservice. Okay. Meanwhile, while that is running up, I'll quickly create a model object, since we want to push this information from push the information to database and read it from the database as well, and then we'll move into the Liquibase. Okay. While this is up, let me just check for the swag. Okay. Don't have the API. So that's the resource which you can simply try that out. Okay.
There is some configuration by which you can avoid those other
Yes,
things.
I have kept it for all right now. So
Fine.
Okay. Okay. So I'll quickly create a model object. Package model. Okay. So here again, this user would be the old conventional way entity. I'll jump into this. Okay, I need to enable all the dependencies first. So Spring Data, Liquibase, I'll enable it for now. That's fine. Okay. 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 All the meaning for this entity and table, why we define it as an entity, how is useful that entity is while we are querying, writing HQL. All that information I'll be giving in the next lecture, which is specifically on the ORM. Again, a simple little pojo with primary key, ID, private string, first name, private. Okay. @ID, generated value. What's that? Generation type, I guess. Strategy, sorry. Okay, and for the getters and setters, as usual, I'll keep the data over here, Lombok's data, and one no-R constructor as well. So we have the model object here. I'll quickly add the configuration for the database, which we can essentially find it, all the configuration on this URL. It keeps updating. So mind you, are referring to the correct release for the properties, because sometimes it keeps changing. For the Spring data, data source, sorry. So for the data source, you have all this key, what we need to set up. I have this over here already. I'll just pick this up for now. So keep the liquid base disabled. So I have that project phone book, and that database should be available over here. Oops. Okay, I'll just drop them. Okay, project phone book, that's it. Okay. Well, this is here. I have the model, I have the resource. So now I need to create the repository for that, so that it can persist. So user repository. So this is responsible for persisting the information into the database. So it comes with bunch of the methods which we can use, or else we can write our own queried methods, we can say. So this essentially extends CRUD repository we need to, and the entity over here for this one is the user, and the primary key for that is integer. And this one is a repository, we need to annotate that. So ideally, in the best practice way, controller is the place wherein you can validate your inputs. Service layer is where you write all the business logic, and repository is the where you communicate with the database or downstream services. But since we're using Lombok, we can definitely add some annotations which will do the validation for us, which is not null for now for these two. I'll directly call the repository, but as a best practice, what it should be called from service layer usually. So user repository over here, and I'll mark this as final so that it can inject the bean. Okay, so I have this repository. So one other thing over here is now I have this DTO and I have the model over here. So converting from model to DTO is pretty much straightforward. But for complex, yeah, for next session, we'll have the configuration wherein inner objects, how can that mapped from flat to nested object, how can that be mapped? I'll be showing that. But for now, we can definitely convert that rather than doing get set. We can convert DTO to model by using the model mapper. I need to add one model mapper. One sec. Okay. Okay. Okay, this one goes here. I need to refresh every time. Okay, model mapper is here. So I'll create a bean for model mapper. So this model mapper definitely. So application config. So all my configurations will go into one configuration file, which is here, and it will create a bean for model mapper. I define that as a bean and return new model mapper. Okay, so now this I can now easily auto wire it over here. No need to auto wire if we have used Lombok's data. So model mapper, that's it. So from model mapper dot map, what is my source? Source is the DTO, and I need to convert that into user object. So user dot class. So this essentially will give me user object, and now if this user object I can use it to save. So repository, the interface what we just extended, it provides the implementation for many operations, common operations that we can definitely do it, like create, update, upsert, delete. All those methods are available. But if you want to create some complex querying, like join on different tables, we can use the native query, or we can use the Spring Data as find by uh, completer. I'll give you that brief later on. So for now, I just need to save. So that's the user object. It's saved, and once it is saved, I'll return the response entity, which will be user, and I'll pass this user, and I'll say HTTP status. Okay. Okay. So change the return type. Okay. Fine. So this should push the data into the database. Um, that's fine. I have the configuration and repository in place. That should work. Okay, I'll just bounce the server. Oops. I guess, and I need to stop. Okay. The one of the configuration over here is, I need to stop. It won't pick it up. The Spring JP Hibernate DDL Auto. So what this does is, if there are different options like create, update, and none. Usually, what happens when you have an entity, for instance, this entity, if you want to create a table into the database, which in the practical world we never keep it as create, but it should be always created via scripts on the database, and it should be none always. But for now, I'll keep create, and then we'll move on to the database to see how that is done via scripts. I'll just run this so that it can create the table as well for us. Meanwhile, while I have some time, I'll quickly add some properties because I need to demonstrate how a configuration file. Okay, I think I haven't added the MySQL driver here. One sec, it is not able to. MySQL connect. MySQL. Okay, let me just. Okay. While this is spinning up, I'll be demonstrating one other thing is how to read the properties from the properties file. One of the common way is the @value, but when we have bunch of properties that need to be read from property file, so there's a better way. So I'll create few properties. So I'll keep the liquid base as well, because by default it looks for a specific location, or else I can disable it as well, keeping the dependency, but I'll just remove the dependency for now. I'm sorry, my IntelliJ is little, even if I disabled it, kept it in memory, so it was trying to look for that. Okay, so essentially this should have created the table in the backend. Okay, that's the table. Okay, that's empty for now. I'll quickly do it via Swagger and see if that is executing. Oops. Okay, that's the primary key that's generated, and that should be in the database as well. Okay, yeah. So now this is all good. Now we'll move into the Liquibase. We should never using Lombok is a good practice for developer Tanmay. Uh, Lombok specifically it omits the boilerplate code like the getters and setters, which is essentially so for now it is just a two parameter attributes within the class. That is why it doesn't make sense. But definitely when you have bigger pojos, bigger models, it definitely makes sense. And writing getters and setters is not a good idea, so it works with an annotation, so Lombok works fine. And even auto wires where I am not auto wiring any of the beans here. So essentially what this data does is on the Lombok official page you can check, it creates a constructor, parameterized constructor, and injects that bean. So essentially when you mark it as final, internally it is creating a parameterized constructor with these two parameters and injecting the beans. So we are avoiding a lot of boilerplate code here. And on the official Spring documentation as well, they have suggested not to use the AutoWire going forward because that will be deprecated. So constructor injection is the better way because we have uh, we have uh, like detail in our mind, like what bean is going into which class from, if we push it from the configuration or we do it this way. Okay, I'll quickly start with the Lombok. Uh, I guess that so. Sorry, Liquibase. I'm sorry. So enable this on Liquibase core. So yeah, I was explaining why we require a Liquibase over here. So when we have multiple developers working on same, okay, uh, uh, when we have multiple developers working on the same module, there would be some kind of database change which developer one has been doing, and we cannot connect to a development common server, and that will essentially lead to failure because we don't have the either the entity updated or our database updated. So Liquibase is the best way to keep everyone in sync and to have the change log, change set of what is actually being changed on a particular table. So this can easily be done by using the Liquibase. Liquibase dependency has been added, and by default it looks for the change set file. uh, on their official documentation side, they have their XML presented, which I have copied over here. Is this the one? uh, okay, I'll create that master file. I'll create file. I'll explain you what that is. So I've kept a specific name. So change log hyphen master dot xml. Okay, hope Liquibase is there. Okay, yeah, this will go. So whatever scripts you want to execute will include those files over here in this master file, which is the change set, which will keep the log of whatever changes have been done to the tables pertaining to this specific microservice. So now that I'll create one release, for instance, there would be multiple release which will, and you don't want to combine them. So I'll just keep as release one. And in release one, in my first release, I'm creating a user right now. So create user.sql. So essentially that's the SQL file what we need to write, and I have that file over here. I'll just use that as is. So that's the author, that's the key, that should be unique whenever you're executing, and that's the first. I'll reframe this correctly. Last name. So ID not null, auto increment, first name, last name, and first name should be, no, I don't want that. Okay, and drop table user if exist. So this is added. We have created the file. This is enabled, and I will. One other thing what I need to do is I need to disable this. So in the normal production environment or any of the coding standards, we just need to disable this DDL auto. It should never create, the Hibernate or Spring Data should never create the tables from the entities. It should be responsibility either of the DBA or from database migration scripts. So I'll do it none so that it has been disabled. I'll drop those tables for now so that we can see that is getting executed. Drop table. Okay, so that's dropped. I'll just spin this up again. And if you can see, everyone, I think I need to extend this a little bit if you're okay, because it took a little while than what I anticipated. So I'll be extending this. Okay, so there is some issue in my script which says, sorry. Oops. Oh, the bracket is missing. Okay. 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 So now if you see this from the log over here, it is now for its own, for Liquibase's own purpose, it has created the change log file, which maintains all the change log information, what scripts have been executed on which table. And that's the script which has been executed, and that's for the key. If I look into the database now, which is here, so that's the user, so that's the empty table right now. The change database change log, this tables is used by Liquibase to see if it needs to be executed again when I restart it. How that it maintains is specifically by the key. uh, the key what you write, like the ID and the key. So specifically what you mentioned, well, this one, this is important. Now if I spin this up again, it won't create, it won't even try to check it. So if I just spin this up again, so essentially now just imagine if you are into sprint 2 or sprint 5 and you want to update this user. So what you will do is you will create a new release folder over here, create an update user SQL file, and add the essential columns, which we will be doing it today. I'll be updating the same user with some more fields like created by created date, updated by updated date, all that information, and then we can see how that can be used. So this is a best way. Now if a user, if a developer checks out this module and runs this, it will just execute, because if the database is clean slate, he has never run the scripts, it will automatically create the table, and we can even keep some dummy data to be inserted. So essentially we'll have insert statement insert statements over here, wherein it will populate it with some dummy data if required, but usually it is not recommended. At least the table creation is fine for now. We can definitely make use of the profile. If I can quickly show it over here. uh, Okay, I'll use a command line runner to showcase both uh, like profile thing. So runner class. So Spring comes up with command line runner. Okay. Yeah. And component and final user repository user data. It will inject that. We'll create a user new user. We can definitely add a builder pattern as well if required. So you don't need to do a get set every time. We can use builder pattern, and my command line runner is here. Set Is it last name? Okay. Oops. User. Okay, so this essentially will run. Okay, thank you. So well, when I will execute this command line runner, what it does is it once all the beans are loaded, it executes this. So I'll just run this again now. No, and I'll, what's that? Okay, I can't use the program. Okay, so what this does is essentially it creates the entries into the database once all the beans are loaded. Now, if I want this to be executed only if I'm running it locally, we can do that as well by using the profile. So basically what you will do is you will just mention this at the profile and say if it is local. So that means when it is what's that? First name. Can anyone see what's going on? Like, am I missing anything? First name.
You using the entity or are you using the Pojo?
Ojo. No, I'm sorry, entity. I'm using the entity. That's the one over here. Camel casing is converted into underscore. So Veena, that's for you. So usually when you have the camel casing, it is separated by the underscore. But
maybe you need to use JSON annotation about to specify what it has to be passed as.
sorry, I'm sorry.
JSON property, like because it's going as first underscore name, like database will be reading like that.
No.
I guess in a table it is first name, it's not first underscore name.
Usually what happens is when you have the camel casing, that converts into the
let's see what is in the table.
It's
First
underscore.
name. It's first name.
Okay.
So just give a column specifier.
So you can add a column annotation.
Yeah, but that is that is not required.
He remove that underscore. No, it is the underscore which is giving you the trouble right now. Or
name.
So for some reason the naming strategy did not work. We can figure that out later.
Yeah. It's weird. I think that makes sense because still
it is going as first. First underscore name.
Okay, I'll have a look because this I haven't seen that before. But just to give an heads up.
Just make that column name as first name without a camel case. And in column at column.
This
At
one.
column. Yeah, the first name is in camel case. Just make it as first
Hmm.
name. Just
Yeah.
name.
No, he says remove the underscore and remove the.
Remove the underscore. Remove the
Yeah,
underscore.
remove.
Remove the underscore, you mean to say?
He
Yeah,
is saying
just
the
keep it
camel
as name.
case is
Small,
giving me the
small case.
problem. Remove the camel case.
One person, I'm sorry. One person. Sorry.
Small case in. Like instead of camel case, keep it as small case in itself.
Okay. That that is like
Yeah,
we
but
are not
please calm
addressing the
down.
problem.
We are not addressing the problem.
Yeah.
You might take a little longer to
Rohit,
address the problem. That's not.
Rohit, I guess the table is already created, so the updates is not getting reflected. I think you need to either drop the table or you need to add some configuration to update the schema when anything is changing in entity.
But this one, if you see,
Yeah, DDL auto should be update.
no, it should be none, right?
No, it's fine. It's none. It's fine.
It's none.
Your SQL, what did it have? The create SQL?
Drop table if exists, but
Yeah, so you have created the column names as that's the reason he's right. You have created the column names explicitly, okay, without any underscore or anything. And it is
usually what it does is Spring Data, when there is a camel, it separates that out with the underscore. So I guess that is my bad. Either I can someone just suggested a simple complete name or have the separator like this. So
so it was just the manual SQL which was not bad.
Yeah.
Which was not good. So that's okay.
Okay.
At least we figured it out.
Okay, I'll just push this. So essentially, what I did was,
so you can remove those extra column annotations.
Oh yeah, because that is actually not required. Thank you. Okay, so I have changed the ID. So
but you have to execute that SQL. Which
yeah, it will. I've changed the ID, so it will.
But what? Okay, it will also drop it, right?
Yeah.
So actually, very brave of you typing everything. Not everyone can do that.
I got a lot to cover actually. The best practices. I'll just speed up a little bit now. Okay, so yeah, that's executed, and the reason you can see table created and the entries has been created, and the only reason being I've kept it profile as local. If you want to keep any specific thing, you can use a not over here. So this won't be executed or this component won't be loaded when if it is not a local profile. So that's the meaning. So profiling helps us to segregate the configuration plus creation of beans based on the profile what we are loading. So in local profile you might load some other configuration with just say like Postgres, and in QA or UAT you would do with that with Oracle. So that is useful, the profiling thing. After this profiling, the configuration, I'll quickly cover the configuration part and then the best practices. So the configuration thing, as we all know, we have been using the @ value, but what if we have multiple things over here? So one other thing here we can do is we can create a class, let's say application configuration, and I can create annotate this with @ configuration properties, and we need to specify a key. The advantage of using the YAML is, okay, you can use the properties as well, but the advantage here is you don't have to repeat this thing, the common keys in front of the actual keys. So essentially it's like app service authenticate user, app service validate user, nothing like that. So you can use it in the properties as well, but in YAML it is like intended, like it gives a proper approach like what we are doing. So the common key over here is app service. So what I'll do is prefix. That's my prefix. I'll keep app dot, what's that? App dot service, and I'll create the beans attributes over here, what I need to load. So authenticate user, authenticate hyphen user is essentially camel cased. Authenticate user. I'm using Boolean. You can use list, string, numbers, anything. Validate user. Okay. Again, getters and setters are required, so I'll use the data, and I'll create. No, our constructor is not required. It doesn't require. So authenticate user and validate user. And later on, what I need to do is I need to tell enable configuration properties. So we need to specify what configuration properties you want to load. You can pass it as a list of different properties or just one. For me, it is now application configuration, different names, sorry. So that's one of the class which we have just created. So what this will do is essentially all these values, now just imagine there are 10 or 15 values against this key. All these values will be populated, and you can simply inject that as a bean into the class. So I'll use this class, and again, since that is a bean which has been created, I will create application configuration. Okay, I'll okay, we can do a logger as well over here. SLFJ. I'll just log it. I don't have any other place, so uh, log dot. So application configuration. I'll just do a toString for you to see that. Okay, to see if that is getting populated. So let's spin this up. Okay, I'll just hit this again. Okay. I guess. 4. Okay, you can see that configuration has been loaded. So you can make use of that configuration in your service layer or controller, anywhere you like helper methods. So to check. Now, there's one other last thing what I need to show you in that configuration is the nested one, which is within this app service. There's another thing which is authorized, which is like an inner class, and it is having one attribute. So how we'll demonstrate that? I'll quickly show that. So in this case, I will create a class, a static class, I mean to say, a static class, and the name would be the same, that is authorize. So essentially that will be authorize. Okay, and same goes over there, public boolean, and what's the name? Authorize user. I'll just authorize user. Okay, and data over here as well. So what this we can do is essentially Authorize, so private. Okay. Fine. I had, while that is spinning up, I had a few suggestions what need to be taken up now that we have a full-fledged microservice, not that much a production ready, but yeah, we have the scope ready. Now I can see I might have a microservice which will be having this common configuration, which will I have to repeat. Let's say a configuration for Swagger, configuration for this model mapper, and if the uh, application grows, we have to keep this as common. And same goes with data and model. Right now I'm in user microservice. Now assume you are in the address microservice. You might need an user DTO and model in address microservice as well. So what is the best way over here? What you can do is essentially, uh, this will take a while for me, but I can show you in another example over here that you can create some common configuration module like this, which essentially my common configuration is my application config, which gives me the model mapper, and my configuration, which is specifically for Swagger, which will give me this. And now this project, essentially this very project will go into my every microservice as a dependency. For instance, you can see it over here, Titan common config. That config has gone as a dependency. So my microservice is not concentrating on the configuration anymore. What I need to just do is I just need to add import that file. So Swagger config is coming from specifically from this common config. So I'll just need to do an import over here, and that's it. I don't need to add the configuration. Same goes with the models and the DTOs. The models and the DTOs, it can happen that later on, if you have a single database, if it's a single database, you have to do with this configuration, because you don't want to duplicate POJOs, models, and DTOs in every microservice. So it's worth that you create these DTOs uh, and models into a separate project, which is a common module, and then inject it into your uh, microservice, so that you don't need to create those models and DTOs every time. You can just simply import it. So that was one of the best practice what we need to do. So every microservice later on, sorry.
I would. So there are two schools of thought in this. Actually, there is another school of thought which says that other than libraries like Spring and the standard things, we
Mhm,
should. There's a school of thought which says don't attempt to create your own shared libraries.
mhm,
The reasoning, there are mainly two reasons for that. One is you will have a versioning of those libraries and your services will have an additional dependency, and you're kind of constraining every service to use that library. Another is the coarseness of a DTO
mhm.
may not necessarily always remain the same in each service,
Right,
which basically means I might be using a customer, but the customer may not always have all those fields in every service.
right.
In certain fields, I may only need a phone number. In certain services, I may need all the details. So if you bring them all together through a library, you're kind of forcing the coarseness. So there are two schools of thought, and it is ultimately there are pros and cons for it.
Mm,
There is a company called what was that company name? There was recently an InfoQ article about how this practice of shared library forced one company to move away from microservice back to monolith, because they had built this big bunch of shared services libraries, and monolith was the only way they could manage it. So there are different schools of thought for it, but uh, whatever works for you, right?
But I guess if we are keeping it in a shared library, definitely we can maintain the versioning as well when we
Yeah,
hook it up with
but
the.
so the only thing is what so there is a what's that there's a very recent article. Anyways, so the point is it adds centralizing things, you know, and it adds a lot of governance. It restricts people from making changes in that shared library, because you make one change, it will affect every service. It increases your testing, and so there are a number of reasons for not doing it,
Mhm.
but I use whatever works for you. But
I would
I'm
say.
just giving you a school of thought. I'm just giving you an official stand. It's considered shared libraries in microservice world is considered an evil practice.
Uh,
Uh,
I,
uh,
I would say sometimes governance is good. Coming the from the project what I'm coming.
yeah.
That's it.
So whatever works for you, but keep in mind,
Mm,
officially it is a bad
mm,
practice.
mm.
But whatever, yeah.
Because this approach was very well suited for my last 3 or 4 projects when we
Yeah.
hooked up with
I'm
the
not denying that. So
Artifactory
see,
on Access.
yeah, I'm not denying that. What I'm saying is, we are see. Ultimately, it's also the scale of the project. Maybe the project is not so huge, and depending upon we are not. If you are making a Netflix, maybe the issues will be different. So that's it. Whatever works for us, but just keep in mind that officially this is a bad practice.
Mm,
I'm not saying you didn't take the benefit of this. You must have taken a benefit. I have also taken a benefit of this, and I think it works well in small projects. When it starts growing into a huge number of services, it may create problems.
okay. I'll
Okay.
read I'll read about this. I'm not convinced.
Yeah. No, do read about it.
Yeah.
It's a formal evil practice. It's listed as an evil practice, which is not against what you are doing. It's only theoretical evil practice. Okay.
Okay. Okay.
And it's a evil in certain scenarios. It may not have been evil in, and I too have used it, and I didn't find it evil,
Mhm.
but officially it is an evil practice.
Okay. Okay.
Okay, all right.
Okay. Yeah. Okay. So pretty much it. I have covered everything. What I'll do is I'll push this code to Bitbucket, and next week when we meet, we'll take this Liquibase migration forward with Spring Data, and yes, querying the database via Spring Data query, native query, and fetching the data through StoreProx as well. So that will be it.
Right.
And I'll add one more microservice, which is an address microservice. I thought my typing speed is fast, but it is not. I'll create one more microservice because it will be helpful in the third session when we use the API gateway. So I'll push this to GitHub and publish the link, so you can have a look.
Yep.
Hey Rohit,
Yeah,
I would also like to show the wildcard, using a wildcard in the microservices.
wildcard.
Is it Tanmay?
Yeah, hi Raghu.
Hi.
Hi.
What is wildcard? I'm sorry.
So what API response, we don't know which API response we get. So through wildcard, we don't know. Like, do you know the template, like T template you use?
Uh-huh.
So for like as wildcard also we can use in a response entity where we don't know what we want to show, what the response we would be getting.
Oh,
So there,
you mean
He
you
was
wildcard.
want
talking about
to
the question
create
mark.
a.
Question, no, he is talking about the response entity with the question mark. You have put a user, right? He wants a
He wants something
question
like this
with
where
the
on a
no,
div.
not
Yeah.
that question mark. He
No,
wants to
not T, the question mark.
question mark.
Oh,
Not the
okay.
question mark.
Okay. So that essentially we have to create another response pojo over there wherein we can bind all this. So there are few things which I need to cover. This response entity I highlighted as the exception handling. This is all good scenarios. What about in the case of exception handling when there is a bad request or not found? All this or application error. So everything has to be wrapped up properly and given a response. So that is done through controller advice. Haven't
Hmm.
covered that right now, but yeah, I'll add that for the next week as well.
And Tanmay, why do you want this question mark?
Just to make a generic, we don't know if what is our response from the backend or any API. So this would give us like we don't need to care about what is the response. We don't need to map. So this
But I would
question mark would help.
actually like it not to have a question mark. You know, I would rather have a defined object and let the controller advice take care of all the other exceptional flows. So the main flow is already encapsulated here, and anything else he will
I
explain.
have I have seen means use sometimes what the response some API has changed the response and it is not the
Yeah,
user now.
yeah.
So there's a complexity then
Yes.
somewhere it will break.
Yeah,
That's the
sometimes
part. Yeah.
ideally, you know, you also have to document your API. So if you have
Yeah,
an unknown
exactly.
if you have an unknown object, it is hard to document it. So rather than have it unknown, it is usually nice to design your API in a manner that it returns a known thing and have another method which returns something else. Sometimes people write APIs which will depending upon the logic, it will return a different kind of an object each time.
Yeah, yeah,
So
yeah.
that it's harder to explain what your API is doing in Swagger documentation for those things.
Mhm.
Yeah, and more our part also, people also I have also used in giving a like user resource, creating a T template class and like that
Okay, that
generic class.
you want to
A
you can
common
use generics.
response
Yeah,
object.
yeah.
Yeah.
I those things we can do, but when you're using repositories and
Yeah.
all that,
Yeah, yeah,
the need is
that's
less. The need is less.
yeah,
Oh, in the
yeah,
older
yeah,
school, we
exactly.
used to do that. In the older school, we used to use generics ourselves, but now so repository itself is handling your generics.
Yeah, 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 exactly. It is the plugin which handles everything and
Yep.
Okay.
Okay.
All right.
I believe we are wrapping up, guys. Thanks, Raghu, Aditya, and somebody who's been named as EC76335. I'm sorry, I could not acknowledge your name. Thank you, Rohit, for a fabulous session. Yes, just like Raghu said, I believe that it's really tough for somebody to just come forward and code live in front of everybody. That's really, really gutful.
Yeah.
And thanks, Raghu. You were really participative, and I'm glad that for the very first session, we have somebody who was participating all the time and was helping out throughout the session. So really glad to have somebody like that. I hope you all had a good learning time, and we would be connecting soon again next week for another great session. Yeah.
Okay.
Great. Have a nice day
Sounds good.
ahead, everyone.
Yeah.
Thank you so much.
yeah,
Thanks
that
again,
was a
Rohit.
good session, Rohit.
Yeah. Thank you.
Yep.
Cheers.
Very nice.
Thanks,
Very
Rohit.
heroic.
Thank you.
And
Thank you. Thank
yeah.
you.
Thank you. Cheers.
Thank
Bye.
you.
Thanks, Rohit.
Yeah. Thank you.
Rohit, can you share this recording with us?
I'll share
But
the
Rohit, you have created your microservices and you were saying that you're going to push into Git.
yeah.
I would request please share the links with me. I'll be sharing the links as well as the video details, everything with the team. Yeah.
Right.
Rohit, I'll be sharing some URLs to you also.
Sure. Sure. Yeah.
Sure. All
Thank
right.
you so
Cool.
much.
Yeah. Thank you.
Thanks,
Thank you.
everyone.
Thank you.